Good afternoon, everyone, and thank you for joining us today. I want to thank everyone for coming in, and we'll probably see a couple more folks join, but I want to thank you for joining EGSA's free webinar today, presented by the Microgrid Committee, Mike Murray, Tony Mente, and Don Harris, and they're going to be sharing this presentation with you. And I'll turn it over to Mike so he can continue with the introductions. Mike, you're on mute.
It always happens. Okay. Yes, I am Mike Murray, the Microgrid Committee Chair for EGSA. Ageto is a microgrid controls company doing commercial industrial scale microgrids throughout North America primarily. The Microgrid Committee has been going for the last 2 or 3 years now and really starting to grow and gain some traction in the space at EGSA, and we wanted to take this opportunity to have a webinar before the show in Las Vegas to kind of go over a little bit more about the energy storage market. So at the show in Las Vegas in March, we're going to have 2 educational opportunities as part of the show. One is going to be on CHP, or combined heat and power, and the applications that can provide to on-site generation. And then we're also going to have a second educational session on energy storage and those applications. And this session here with Don from FlexGen is kind of a preliminary introduction, what your appetite for learning more about energy storage going forward. And this will be a starting point for our conversations at the show in Las Vegas. I kind of want to just, Don has this picture up here of an energy storage system. It has 4 energy storage systems, we'll call them. So you can see the 4 transformers there. And I'm just going to kind of run a poll. I'm not sure if there's a good way to, I don't know if you can raise your hand maybe, but kind of see how big you think each of those energy storage systems are. And we'll let Don let us know, because I'm actually not sure, because I haven't worked with this size system yet. So for the first one, let's say, do you think each of those is 250 kilowatts by 1 megawatt hour? You can either raise your hand or just think of your answer. Not sure if that's actually working. I didn't check all our technology here. The second one is, do you think it's a 1 megawatt hour, 4 megawatt hour system? And then the last one is 5 megawatts with 20 megawatt hours of energy for each of those systems. And we'll probably let Don start with that. But just to give you a quick overview of what the session is going to be like today, we're going to start with a quick presentation from Don on energy storage and FlexGen, how they see the market, where the market's going, what the different applications are for energy storage. And then we'll have some time for Q&A and discussions. I'll also be moderating the questions, so please drop through the Q&A portion down there any questions that come up during this presentation. So without further ado, I'll hand over to Don to introduce himself and discuss his presentation.
Hey, Mike, thanks so much. Excuse me. And I'll get to that answer. It's a great question, and I can interact with that here in a second. But first, just let me introduce myself. My name is Don Harris. I work at FlexGen as a VP of software sales. We can talk about our EMS and how software interplays with batteries, as well as C&I, which, as we talk about, C&I stands for commercial and industrial, and just the differences between different system sizes. I've been in the energy storage business for about 15 years. People always say that, how that's relevant. I've been at FlexGen for about 1 year. My first 15 years were at Tesla, and then I spent some time in a company called Zinc, which did a zinc-based battery. It's called Mant Energy, did a zinc-based solution. but I was at a company called Solargraph, which got acquired by Enphase. So in and around the battery storage for quite some time. 1 year at FlexGen, and you know how that's relevant is it's changed dramatically in 1 year. We have just seen a massive growth in the industry of battery storage in the last year, specifically in the size of the systems that are getting interconnected or integrated into the grid or into behind the meter applications. To start with this picture here, and before I get into the presentation, I love starting with pictures to give people visualizations. And I like Mike's question about how big is this system. So this system right here feet, and there's 2.5 megawatt hours of energy in each cabinet. They go to the PCS. There's a transformer, and this is what would be a distribution level project. So this is going right into the poles here, and you can barely see in the corner. This is a distribution site. This is the distribution site that this power is traded into. The application here is energy trading. They're just trading this power right into the grid. A few more pictures, and as we talk about scale, so this is 10 megawatt hours. This was done about 2 years ago. Last year, we did this 110 megawatt hour site. So this is, each of these packs is 372 kilowatt hours. And you can see there's 33 different sets of them. They're each about 10, 8, 11 or 12 megawatt hours. And this is also for energy trading. And as people always ask, what is this empty spaces here? This is just meant for augmentation. So this requirement is for 20 years. The power to be at 110 megawatt hours into the grid. And so as these age, you just add battery packs behind it to keep the power requirement up. And as we talk about system size, right, that we just went from 10 megawatt hours to 110 megawatt hours. FlexGen's scope or FlexGen's capabilities we've done systems as small as 500 kilowatt hours. And I can show you some of those, but we put them in a Flexpod. And then our largest system contracted is 972 megawatt hours, one site. So you can see that the scale and the growth is just enormous in the last couple of years. I would say this 110 megawatt hour site was our largest site when we did this a year ago or 18 months ago. And then getting down more to, so those are the big pictures I like to show. Getting down more to the microgrid, and I think that's more applicable to this webinar, is this one right here is about 5 megawatt hours. It's 15 of these cabinets. These are 340 kilowatt hour cabinets each. You can see we're just lining these up on a pad. You've got the MVT and the PCS right here, and this is going into a site, right? So this is 5 megawatt hours of energy going to a site. So you just kind of get an idea of the size and the scale. What I'm showing you here are called flex packs because these are just 340 kilowatt hour battery packs. These would be a modular system, right? It's the more, the industry term, these are modular. You can just put as many of these in each other. As you can see, you saw 110, this is less than that. But you can stack as many as you like to create a custom solution. I'm gonna jump out of this screen real quick because I did want to show you guys one other thing as we discuss batteries, and I think this is relevant to the conversation, is we also have what we would call a Flexpod or a containerized solution. So you saw a modular solution. We also offer these containerized solutions, and these are often done behind the meter, C&I applications at a site, right? And what this is, solutions with both the HVAC, of course, but then you can see here the battery packs and the PCS are inside of this. So it's a fully wrapped solution. I think this is what a lot of people see in behind the meter applications is a 20-foot container that sits on the ground. These are also scalable. It just becomes a cost. As you get to a bit higher of these, it's just a more cost efficient to go to a modular solution, but you can always do the containerized solution. containerized solutions are often used for its simplicity, or its pre-integrated configuration, right? So these can come in, they can be put on the ground, and for the sake of simplicity, you just plug them in. Of course, there's going to be a lot of questions on that, and there'll be a lot of people asking, but they literally are a plug and play as much as battery storage can be, right? So that's why these things are created, that's why they're built, and that's why we've seen a lot of traction behind the meter and some smaller applications for these fully wrapped containerized solutions. I can keep going here, but again, the goal of this is to be interactive. Please feel free to put some questions in the chat or ask some questions, and I'd be happy to answer them. I know we'll have a dialogue at the end, but my goal here is just to give a brief overview and show you guys what we do and be helpful in the energy storage space as we talk about energy storage and generators and how they can interact in different use cases for microgrids. So those are the three pictures. And then I'll start up at the top, and just because I'll go quickly over some of these slides, because like I said, I want this to be interactive and I want this to be the ability to be informative. So again, how batteries work, I think we can do that. But what we do specifically is this integrated battery energy storage system. We provide the best-in-class energy management software as well. So the EMS application, which we're going to talk about software a little bit, how valuable the software is. And I'll try to avoid buzzword bingo as much as I can. I have to talk about revenue stacking when you talk about batteries. It's just that they're dynamic and the capabilities to do so much on site. And that's all done through the software applications, through the energy management system, right? Battery is, a dumb asset, right? It just sits there and charges and discharges at will. You need to put a software application, energy management system behind it, and then you can control that battery and make sure it stays inside its parameters and meets the use case that's applicable to the site. And that energy management system, which we call Hybrid OS, you can see here we have 387,000 or over 387,000 hours of runtime. So it's just got a lot of experience, and then you can see some of these things about our size of our system. We have 3 megawatt-hours installed and contracted. We've got another site that's just that size that's going to be announced soon. This is just different people we support. C&I, we talk about commercial, industrial, solar and storage. I don't know if there's too much of this. Microgrid, in the way that we see it, is EV charging. We've just seen a lot of interest in EV charging, particularly level 3 charging, as people say, look, we have a fleet of vehicles and we want to plug 100 of them in at 100 kilowatts each. That ends up being a pretty big load on an existing grid, right? That manufacturing capability, that warehouse wasn't built for that, or it may or may not have been built for that. And what we can do there is provide storage behind that or at that site. And that can capture some energy from solar if it needs to, but it can also manage that load and either provide energy to just clip peaks if the interconnection is big enough, or supplement energy and provide energy when the interconnection, they can't get the power they need from the grid. You could add storage to supplement that power and combine the two. The third thing here is resiliency, another buzzword bingo, but what makes that so unique is as you talk to a company about fleet management, reliability becomes pretty important because again, they can't go without charge. And so having storage there on site helps them with their, resiliency and making sure that there's always energy at the site. Get through that. We talk about revenue stacking, it's going to come up, but what batteries can do is so much more at the site, right? So a battery can be at a site for switching, it can be there for peak management, demand management, but there's also these opportunities that are coming up, and we're very familiar with market regulations and wholesale energy trading, right? And so as we talk about FERC Order 2222, but there's also places in the country where we're starting to see the capability of behind the meter energy trading. You can add another value to that battery to that site where you can get revenue from the site and also provide the needed load for the requirements of the site. Here's some of our customers. And then, what I do want to talk about is this energy management system, Hybrid OS, or any energy management system. But you can see here, one of the features is automatic islanding. I think that as we talk about microgrid, that's always going to be one that we're interested in for this specifically. But as we talked about earlier, there's all these additional opportunities that a battery system with an EMS on site can provide you. And these are all these could all be part of the solution, part of the standard solution. I think this is always a good visual as we talk about the Hybrid OS ecosystem. There's products inside of this energy management system. The one I want to talk about specifically for this audience is the site controller. So our site controller does exactly what the name says it does. It controls a site. It can also communicate with other controllers on site. So if there was a master controller and you wanted to bring batteries into the equation to help reduce a utility bill or to provide resiliency or to help with some demand peak management, we can speak to the overall site or create the site. And you could and then Power Cloud is like a remote monitoring, or it's a data historian, so you can collect all your information of how the site is working. Sites, if you have all sites in a specific node or sites in different parts of the country or wherever they may be, we can all manage them into one through an application called Fleet Manager. We haven't talked about the other two in more detail later on, but I think these are relevant to what we're talking about inside of for this conference, this webinar. The last one, FlexBidder, it's a trading algorithm, right? So you can use this algorithm to help trade that asset into the wholesale market, like we talked about, and create revenue opportunities at the site. Another picture of a layout. This is just showing people an example site layout. We just saw one of these. This is, again, these are two 20-foot containers now in parallel into this PCS here. Cybersecurity is important. And then, there's a couple of use cases that we've done. Just, I said that these slides can be shareable. I can send them out to you guys after we're done with this. But just a couple of use cases that show people the different applications that battery storage can be used for. This was a peak load mitigation. So this is just someone, a co-op that wanted to reduce their demand charges. They just put batteries up, and as the demand hit, they supplement that power with the power from the battery. Solar storage is always a popular one. We like this one a lot. This is something becoming more popular. They're just doing a transmission deferral. So instead of building additional lines, it's a resort area, and so they have really heavy traffic in the summer, very low traffic in the winter. This battery creates the 5 megawatt hours of load that they can then, 5 megawatt of energy that they can use to help defer additional infrastructure.
Hey, Don. This is Mike. We have some good questions coming in. I just wanted to give you a chance to answer a couple of them potentially. For these projects that you're showing, what is your typical ROI that you're typically seeing? And I know we don't want to get into too specifics, anything confidential or anything, but are we looking at 2-year payback, 5-year payback, 15, 20? And then I guess the second part to that is, what's the life expectancy of these current energy storage systems you're putting out in the field?
Yeah, so let's see if I can answer it. So life expectancies are 20 years. Again, a lot depends on the use case, but the battery pack can last up about 20 years with augmentation. You can supplement them to get up to 20 years. ROIs, again, is depends on use case, but we have some customers that have seen 2-year or 2 years or around 2-year ROI. Some are a little bit more than that. It just depends on the use case, how much load can be reduced, how much trading could happen with that node, right? How much opportunities are occurring. So it is, of course, case by case, but we have seen some pretty significant ROIs, pretty healthy ROIs, just because of the newness of battery storage and some of the capabilities that only a battery can do versus other generating assets. Right, batteries can store energy and can add, instantaneously or within a few milliseconds provide full power back to an application, and that can create a lot of value and benefit for a site that other generating assets can't.
I believe you mentioned in the infrastructure deferral project in Utah, the battery was 1/10 the cost of additional power lines. So I'm guessing that's one of the quicker paybacks.
Yeah, that one was that one was, I mean, again, for them, it wasn't necessarily a payback. It was like, do I have to spend X million or 10X less million, right? Because that deferral, that transmission line was due. They had to provide more power to the resort. And so that one was just an option of less cost, if you will.
Yeah, so not true ROI.
Yeah.
Another question that we had about batteries is, what capacity can these batteries be used at? Is it 50%? Is 100% depth of discharge? And maybe just for some context, if you could define depth of discharge and what is typical, and also maybe cycle life.
Yeah, so the typical cycle life, the one that we would start with is 365, one cycle a day. That's typically what a battery would want to do. That would get you to 20 years. That's what the manufacturers would warranty. That's kind of the use case. We talk about depth of discharge. It's a great question because there's multiple different variations of the chemistry, right? So there's just inside of lithium ion, there's two big, chemistries that are used: NMC, which is nickel, magnesium, cobalt, and LFP, lithium iron phosphate. Right now, we're seeing a majority. Again, FlexGen is manufacturer neutral. We aren't a manufacturer of a technology. We are outsourced, and we have a team in China that goes out and speaks to all the vendors in Asia, South Korea, around the country. There's some in Europe, and we can provide a solution that's best for the site. But right now, what we're seeing is almost every job we're doing is LFP, lithium iron phosphate, and that battery technology, that battery chemistry, has a depth of discharge of 98%. So you can go from full state of charge down to 2% charge with the LFP technology. If there were certain requirements for a specific job, we would look at a different battery chemistry that could help with hitting those requirements. But right now, that's the majority of the sites are the LFP, which is about 98% depth of discharge.
Great, thank you.
Yeah.
Do you have more to? Do you have more presentation material?
There's really not much more. I want to kind of come back and end with these slides. I have one. Where is it? Up here. The history. We kind of went over this, but I like showing this as a visual, and we can end on this and open up to more questions. But you can see, like in 2010, and a big system was 50 kilowatts for us, and maybe for the industry, and I don't want to speak for the industry, but for us, 50 kilowatts, military microgrids, remote locations. And just over the last 10 years or the 11 years, you can see, as some of the pictures, we've seen the 110 megawatt hour site. We've seen the 800 something one that we have under negotiation. So you can see the growth of the industry of battery storage, and the new use cases. Like I said, I don't even have on this deck EV charging, but that's one that's become incredibly popular as of late. Data centers is becoming popular. We're getting more and more calls from microgrids or from industrial sites saying, look, as part of our ESG requirements, we think there's an opportunity here to help reduce the peak load at the site. We're interested in adding storage. It's making more sense and penciling in a lot more places. So, if I could just end on this history of this tremendous growth in the industry, the tremendous excitement we have at FlexGen and as the industry of use cases for battery storage and bringing more of this to the grid. As we talk about climate tech, we talk about the grid transition, right? We find battery storage, and I'm biased because I work at a battery storage company, but it's great because it complements renewable energy and the challenge of intermittency, and it complements traditional fuels. It transitions to traditional fuels and fossil fuels into, providing the store it on location versus at a centralized plant. So we just think that battery storage has a nice play in the energy transition as an asset that can, create on-demand power, provide on-demand power.
Great. Yeah, thanks, Don, for that background and information on the energy storage market. I do want to bring Tony into the conversation as well. Tony is with Generac and is part of the Microgrid Committee leadership team. Forgot to introduce him earlier, so sorry about that. We got some other really good questions coming in. Obviously, a lot of the EGSA membership are more, behind the meter, on-site power generation. Can you talk a little bit more about the C&I market and microgrids, the industrial facilities, some of the considerations and capabilities around interconnect, operating in island mode, around that?
Yeah, sure, absolutely. We're seeing a lot of interesting use cases, behind the meter, industrial, and one of them is just being this, I mean, walk through switchgear, right? So one is being, hey, we're thinking of using batteries to replace a possible UPS, right? And it's a really interesting use case that we're looking at. And of course, like everything, it has to be individualized, but there's opportunities where a battery can come in with that really short response time and help maintain stability of some pretty significant industrial plants and some pretty significant, lines, industrial lines. And again, it's an application that batteries can do, with an asterisk of let's look at what's there, let's look how much gear is needed to make those switches quick enough or fast enough. But it's something that's definitely gaining a lot of traction. The other one is having this available energy. So, resiliency is always one that people want. I need backup. But now what they can do with a battery is they can build it. Maybe they need 2 megawatts of backup and they build 4 megawatts, or maybe they build 2 megawatts. They look, we're pretty confident that the grid won't go out today, or whatever the use case may be. These are developer questions. They come to us with this. We don't suggest them this stuff, but you can use that energy to trade. You can use energy to clip peaks, and maybe the 10 times a year where you think an outage might be imminent, you don't use it, right? But just trying to find different ways. Like I always tell people, battery prices, they've been coming down for quite some time. Unfortunately, we've seen a little bit of a spike here in the short term. But the reason we're seeing more and more on the grid is not because it's because the prices have come down and they've become more valuable, right? People are figuring out ways to utilize them more to create more revenue opportunities. And that's why we're seeing a tandem of both the battery prices coming down, but also the use cases going up. It's really helped drive the demand on these applications behind the meter or on a site, and getting creative of how we can use a battery differently than other assets and complement other assets. It's been a conversation that we're part of. We don't lead that conversation, but we just help them, provide them with the technologies, battery storage and the hybrid system to help them with that.
Yeah, I think to add a little bit more, about asset selection as well, like there's a great variability in the capabilities of the different inverters or PCSs out there. Those terms are kind of interchangeable, but Ageto has a few projects operating where the backup battery system will take about 2 minutes to back up the site and to boot up to black start the site. Whereas other inverters, they can go from 0 to full power in under 10 milliseconds. And they're directly controlling the islanding contact or motorized circuit breaker. So in that case, the entire factory can actually be backed up seamlessly if there's a fault in the utility grid. And that way, like you say, you don't have to have the big UPSs for the factory to have continuity on the site. Actually, this picture behind me here is from Mexico. It's an industrial facility. It's about 1 megawatt load. And we have a battery system for the full facility backup. It only has about 1 hour of backup power. So we can't, run it for a long outage, but that's why they have backup diesel generators as well. So we go, immediately onto batteries during a power outage, and then once the batteries get 50% discharged, we'll start the generators and allow that to, provide power and energy to the factory so it can continue operations. But some other ones might take 30 seconds to black start, so then you're going to need a UPS or other means to provide backup power.
Yeah, we're getting a lot of those. We're feeling a lot of those inquiries of what is the response time. Or we have different. You're right, absolutely. The inverters can control the black start capabilities and some of this other hardware there, but it's options that we're exploring at FlexGen that at other companies we didn't, and that's just because companies are our software capabilities are pretty robust, but also the needs becoming more relevant.
And like you said too, with the value stacking, these factories, they might have really high peak rates in the evening, and they might feel comfortable, like you said, using half the battery for energy arbitrage or energy shifting to save. This sometimes they can save 15 to 20 cents a kilowatt hour for every kilowatt hour that's shifted to off-peak times, which you do every day, and it does start adding up pretty quickly. Demand charge management is also really big, especially in California, where some of these commercial utility rates have $35 to $40 demand charges, and those can be modulated second by second to shave those peaks and reduce the utility bills quite drastically. Another question that came in, are you seeing much the US content requirements, are those adjusting or affecting the supply chain, or are you seeing those being barriers in some of your projects?
Yeah, so the US, Buy American, I think is what I've heard it, and we can access that. They don't create barriers, they just create additional costs, right? So right now, there's a few manufacturers in South Korea that can help meet the requirement. We're really excited for the next couple of years, I hope months, but for new battery manufacturers in the US to come on board. We're an integrator, so once these battery manufacturers come on board, we're going to work with them, we'll partner with them, and we can provide solutions and integrate those into the site that will meet the Buy American requirement. The last couple of months, we've just seen a pretty significant, and I don't think I'm going to drop a bombshell here, but a pretty significant supply chain disruption. And so it just makes everything a little bit harder. So while those requirements, everything's been a little tough the last couple of months, but as we get out of this, those suppliers are going to catch up as well. But right now, there's a lot of Chinese batteries that they're just got a big manufacturing capability, a big manufacturing plant. So those are still available, whereas some of these Buy American requirements are just becoming temporarily disrupted with the everything going on in the economy.
And there's not really too many options for Buy American battery cells or
Right.
modules. Obviously Tesla in Reno, Nevada, and then I know there's been a few announcements about Core Power building a gigawatt scale factory in Phoenix area, which will be coming online, I think, next year now. But yeah, Buy America is pretty tough right now on the cells and modules for sure.
Yep.
Another good question coming in about on the integration side. What all goes into building a container? The electrical connections, but also like HVAC and keeping the batteries happy, in these extreme conditions that you can get out in the field.
Yeah, so we can talk about two pictures here. So this one's really the better one. Let me pull this one up. So you look at, perfect, a Flexpod, and we saw it here. So this gave us a good example of what's in it. So this one is a Flexpod. These are containerized, these are fully wrapped. Sorry for the delay here. So here's the HVAC unit right here. So this is a 20-foot container. Here's the HVAC unit. And then inside are the modules and the PCS. Then that's enclosed. And what you can't see is, I think it's side connection, but there's just you can plug in at 40 volts right to there. The fire suppression's in here, you can see right here. So this is fully wrapped, is what we say. When the other ones, those 340 kilowatt hour cabinets, these are air cooled. You saw the HVAC. The 340 kilowatt hour cabinet, or the 372 kilowatt hour cabinets are liquid cooled. So they're running a glycol around the batteries to keep them cool. So the HVAC is not keeping the cells cool. It's actually liquid cooled. So they're a little bit more, that's a little bit more energy efficient to do that way. But then those cabinets have the fire detection, and then those PCSs are customized. It's a more customized solution. So the PCS can be a couple different manufacturers, and that would be specific to the site.
And I think we have some of our attendees from the north of the country. So I know we talk a lot about batteries don't like to be hot, but how about on the cooler end? Are you maintaining heating as well?
Yeah, the HVAC maintains heating. They run in 60 to 70 degrees Fahrenheit. That's what the HVAC maintains them at. We haven't seen, we see more of it going above 110 on the hot side to keep them cool than the cold side. Now, of course, like we've done a project in Siberia, it's really, really cold, and cold's a relative term, but we haven't seen much degradation in the 48 states in terms of the weather.
And I guess too, they generate heat when they're operating, so you don't need as much supplemental heating. It's more about keeping them cool when they are working hard and it's hot outside. Great. Another question came in about the wholesale energy market. How is that working? How does the sellback work? What value streams or revenue streams are you going after?
Yeah, it's a great question, right? And that's where we do we're very familiar. That's where we got our big, 3 years ago, we started doing these, and this is where we've seen these big projects on this wholesale market, these IPPs buying it. We're starting to see this be open to anybody on the wholesale market. And, unfortunately, they're all, well, fortunately or not, they're all different, right? California, ERCOT in Texas, New York ISO, they all have different requirements, different things to buy into. So to be brief, I guess, so in Texas, we're seeing a lot of 1 hour site frequency response. They're just feeding big amounts of energy in rapidly and in succession with ERCOT's needs. In California, there's a lot of capacity requirements, resource adequacy, where they're 4 hour solutions, right? So you need 4 hours to participate. And, so a lot of the batteries built there have a 4 hour site to them. And then, in New York and New England ISO, again, there's some requirements there, but they're specific to the region. And we would build it accordingly, right? So we would look at, or you guys look at the use case, or we can partner with somebody and say, hey, here's the best way to utilize that battery at that node. And then our hybrid OS could act on those commands. But, they're regional, to be clear, to be specific.
Mm-hmm. So far, I think all the conversation's been about energy storage. Is your system working with solar, either DC coupled or AC coupled solar?
Mm-hmm. Yeah, so AC coupled, you can just put these in addition to what's already there, what's existing, or include it. And we can also DC couple these and put in the DC rectifier or DC controller and use the DC power before it hits the grid to use it. So either way, AC or DC, we've done both, and we can continue to do both. Just depends on the use case. But again, another growth market, and with that one, it's just this ITC, right? Like you look at these segments, like EV charging is growing phenomenal just because of the adoption, right? DC coupled, AC coupled, it's all driving this behavior of solar sites needing or wanting to put on storage. And the ITC depends on if you should go DC coupled or AC coupled and some other requirements. So we can do them both. We're about equally getting each coming in, but we can see it in a scenario where, due to policy or due to revenue, revenue obligations, one becomes more popular than the other, but it's just a different connection. Our batteries can do both.
And I guess one thing I've seen on this DC versus AC coupling side is for utility scale, DC coupling is somewhat more common, or it's becoming more common just because it reduces the need for a big interconnect, because all the AC power so the utility cares about goes through one inverter instead of potentially having both the inverter for the solar and the battery, feeding out at the same time. Then also residential actually does a lot of DC coupling. Commercial though is basically all AC coupling from what I've seen recently in the market.
Yeah.
There's also a question about cost. I know we don't typically like to talk about pricing too much, but maybe just some general market numbers of, cost per kilowatt hour, cost per installation. Would you feel comfortable talking about that?
I mean, costs always come up, and we don't want to avoid it, but they're changing pretty frequently, right? Just with everything going on. So you put something on a recording, and then people hear it 6 months later, it can look a little different. But
yeah,
what we've done is these Flexpods right here that you're looking at on the screen, these containerized solutions, we've standardized the pricing. So if you reach out to me and you have a project, I can provide you some pretty standard pricing that we're trying to keep as stable as we can. It's very challenging in these times, but we purposely made these Flexpods, these containerized solutions, an easy to use solution. The Flex packs, again, you can do 2 megawatt hours up to 950, even higher than that. You can do the gigawatt hour if you wanted to. And so the price ranges pretty dramatically there.
Another thing I'll touch on too is a lot of people throw numbers out there that, batteries are $100 a kilowatt hour, $200 a kilowatt hour. Mm-hmm. And you really have to understand what they're talking about when they talk about that. Is that for just the cell over in China? Mm-hmm. Or is it for a module, in China, FOB, Shanghai? Or is it, a integrated system like this Flexpod, I believe, fully integrated with a PCS, fire suppression, delivered to your site in Texas. So all that greatly affects the price. And, I think a lot of people hear, the cell level number, and then they get a quote for a full integrated system, like, oh, that's so much money. But there's a lot of work that goes into building a 20-foot container like this. Fire suppression, fire safety. Can we talk a little bit about, I guess, the fire certifications, the 9540, 9540A, fire suppression requirements, et cetera?
Yeah, so we've got over 2 megawatt hours, 2 gigawatt hours installed, and they meet all the requirements. The requirements are oftentimes, 9540 is pretty standard. That's a system level, nationally or federally recognized. So these fire requirements are county-based, HJ based. We're working on one in Kern County. That's the big one that comes up in California. We should be through that. We've contracted it, and we should be through that this year, and meeting all their requirements as they come up, whatever they may be. Got a lot of interest in the boroughs of New York City, and there's some certain requirements there. And again, some of that comes from the cell level of like, hey, let's be flexible at FlexGen. That's where the flex comes from, and get a different cell technology that could meet some of these things in New York specifically, where they're just saying you can't have certain cells essentially just because of their thermal propagation. So we look at all those factors. The Flexpods are all 9540 certified. That gives people a lot of peace of mind just having that pre-done, pre-integrated, pre-done. These custom solutions, oftentimes are integrated on site, and then we get the certifications there. But we work with the fire chiefs and the fire consultants to make sure that these things are safe. And this is very relevant. So some of these ones you saw the pictures earlier, they're out at a substation, and the fire requirements were met. As we talk to people at universities and we talk to people at industrial sites, they're a little more careful and a little more specific, and we provide that level of detail because they are much closer to the cities there. And we're going to provide them the information they need and do the checks required to make sure that they're meeting them. But yes, they're coming up more and more as we get more into the grid.
Great. Oh, we got the question that just came in. The question is, what are the aging mechanisms? So I guess what degrades a battery over time?
So I don't know if I'll do the best to answer that here, but a lot of it is just the actual chemistry of the battery, the physics and the chemistry of the battery, how it runs. As it cycles, it's losing its power, it's losing its capabilities. Don't know if I have the technical knowledge to get into much more detail than that, but it's a good question that these do degrade over time. And that's oftentimes where we do these augmentation strategies to make sure that if there is a requirement for the for the site requirement, we can just augment them with new battery cells in years 5 or year 8 or whatever it may be to keep the power and energy requirements where they need to be for the point of interconnection.
Okay. Yeah, so I guess a lot of the attendees on this call with EGSA, they'll be coming to the EGSA conference in Las Vegas in a couple of weeks. Where else can they learn about energy storage? What other conferences or associations does FlexGen participate in?
I'm trying to think. So the ESA, I think they just got renamed, Energy Storage Association, seems to have a good resource. I think we're a member of that, and they seem to put out some good content. And then, it's just, storage is, we're still finding our path, right? We're still popping up at solar places. You'll see a lot of storage companies there now. A lot of power conferences. We should be also, the industry should be participating there as well and getting more traction there.
Are you going to
I'm just,
Power Gen and Distributech?
I'm not aware that I'm going, but we may as a company be going. But those are the ones that you're starting to see us more and more at. And then, I just do a lot of reading and trying to follow the path, right? So you read an article and they start talking about it at a co-op and a muni. Then I start saying, well, let's see if there's some co-op and muni places, and we're starting to see municipalities, and I'm sure this group is well aware. Municipalities are showing keen interest in for putting storage for the social good that they need as a municipality, but also for the economic benefit as well as the resiliency factor, right? Like there's a lot of reasons why municipalities should be getting into storage pretty actively, and maybe as they start having conferences that are geared towards civil leadership and civil cities and stuff, we participate in those as well.
Yeah, I guess from a Ageto standpoint, we're seeing a lot of interest from municipalities, civic centers, rec centers, want to have backup power in the hundreds of kilowatt hours. Not a huge load, but in California, for example, they have a lot of public safety power shutoffs. So the utility says, we're going to turn your power off for 3 days. Sorry. They're really wanting to be able to have backup power on site, and it's a lot easier to get a battery sited than a backup diesel generator currently, and especially in California. Right. But then also it's also providing value, saving money on their utility bill with the demand charge management and other capabilities there. So we're coming up to
oh, go ahead.
Oh, no, go ahead.
I was just going to say there's a creative, brainstorm session I had with a customer the other day, and I want to share with this group, and just this is something that I think really got a lot of traction, is this, putting batteries in a city, and having a portable generator that can access each of them, right? Because a power outage may not happen on all 20 strings or whatever the case may be, but having batteries and generators together and finding out the way that you can help, increase benefit and reduce costs by combining the two technologies. I think as we talk about the grid transition, like using existing assets and new assets together is a really interesting and strategic way that could bring a lot of value that, maybe a company here could do because of their relationships with different buildings or different cities that are all at a similar proximity. And it's just these are kind of things I think about and I hear about and I share and I try to get creative. And these are probably brainstorming sessions, but I think there's a lot of opportunity to think about how battery storage and generators work together to provide the best value for the customer and thinking of creative ways to do so. And with our robust software platform, a lot of the times we can achieve those creative solutions.
So we are coming up to the top of the hour. Is your contact information able to be shared, or how can people reach out to you?
Yeah, let me pull it up here. So I'll put it on the screen so everyone can see it. It should be on here, right? Oh, great, it's not even on here. So Don Harris, D Harris at flexgen.com, and I'll send it out maybe after I can put it in a. Of course, it's black, right? I'll send this out too. I'll put it in here. That would be the best way to reach me if there's any questions.
I have a really interesting question about augmentation strategy. Because it's not like you're building that into your designs. Is it a DC augmentation or AC?
DC typically.
Is adding more battery cabinets in?
Yep.
And it sounds like you're kind of moving towards more liquid cooling over air cooling. Is there a driver for that?
Yeah, it's a good question. You know, we're using what supply has. We're seeing a lot of benefits. They're portraying a lot of benefits with liquid cool, and we're just trying to make sure we validate them and talk to our customers about their comfort level with them. You know, right now we have both air cooled and liquid cooled. I like to talk about them both because there's options, and then maybe use case specific, we can talk about which one, if there's a benefit to use one or the other. Oftentimes it's just a matter of how do we optimize a system that makes the most sense.
Well, great. Thanks a lot, Don, for all that valuable information and discussing the market with this group. A lot of good information. And, you know, I think, like I said earlier, this will tee up the conversation in Las Vegas with EGSA at the spring conference. Nathan, any other things to wrap up?
No, I just want to thank everyone for joining us today. A recording of this is going to go out later today. I'll send the link out to anyone who registered. So if you happen to come in late or missed anything, you'll be getting the recording shortly after. And I feel like this was a great primer for the spring conference in 2 weeks. And if you're going there, can't wait to see you there. And if you're not, we have a lot of great speakers coming, and Mike's going to be there with the Microgrid Committee to give us a couple more great education sessions. So we look forward to seeing everyone. That's all I have from EGSA. We'll leave the room open if there's any more questions or anything that might come open, but I want to thank everyone for joining us.
Yeah, thanks so much for having me. It was my pleasure. I hope that you found this up information. I love talking about it, and you know, if there's anyone out there that's got some detailed questions or want to look at the site, I'd be happy to look at it, because I'm a big believer in what's happening in the energy space.
Sure. Thanks, everyone.
Thank you. Thanks, Don.